is gone?
You have two. You can choose. Both me and Chernenko are here.
Both of them are present. Dima and Dima.
So I can start the countdown. 5 minutes past 12 is very soon. So we almost started.
Wie macht Platz?
Okay, so let's start. So welcome to everybody. I'm very happy to see here a lot of our partners, our friends who already know each other. So it's our traditional auditorium, but also some new guys. So I hope that this webinar would be helpful to all of you. Besides that, the recording of this webinar would be on our Facebook page and later in YouTube. So I hope that this material also would be helpful to those who find us a bit later. So let's start today our topic. So the topic carbon farming, we touch it not the first time. For example, 2 years ago, we had a similar webinar. So today we will update what new data and information we have now. And I believe that it is not the last one because we still have a lot of ongoing projects, which we will comment a little bit later to get more and more insight and data about how we can improve organic matter accumulation using the biologicals. So today, our webinar would consist of 3 parts. More or less, we expect 1 hour material. First one would be a little bit introduction from me about us and about soil health. Then we will have a presentation from our scientist and plant physiologist Yaroslava about the mechanisms of work of microorganisms in carbon farming. And then we would have some practical insights from Dmitry Chernenko about how our biologicals perform in this direction. So let's start. First of all, for those who are, I believe there are not so many of those, but those who are seeing us first time, BTU is a group of companies which is this year 25 years old. We have more than 550 employees. With our biologicals, we cover more than 4.5 million hectares. So we specialize in field crops, first of all. And we are the largest producer and distributor of biologicals in Ukraine. Talking about the regional representation, we are quite present in Europe. We also have office in Germany. 11 of our products are registered in different EU countries, and this list is expanding. And now we have new projects in countries where we are still not present, for example, in North Africa, in some Arab countries, in Latin America, etc. We are part of IBMA. We are one of the largest producers of bioproducts in the world, especially specialized in field crops. Most of our products are organic certified, so they are safe. Yeah. Then a few words about the factory. We are ISO certified. We have quite huge production capacities, quite modern, with special equipment for the cleanness of the process and for the good quality. We have special storages with temperature control, which are required for some of our products. We have them both in Ukraine and in Europe, in Germany. And we work with our own museum of strains, working with hundreds of strains in different combinations. So we touch with biologicals few global challenges in agriculture. In general, biologization of agriculture is good for soil fertility improvement, for food security, and for the impact of agriculture for the nature. What we do complies well with EU Green Deal course, for example, in optimization of fertilization schemes, and as well as improving of biological protection. I mean, not improving, but substitution of chemical protection. The topic we touched today is carbon management and the European climate strategy, so we can use in biologicals reduce carbon emissions as well as sequestrate some carbon in soil. More about this a little bit later. Besides that, we participate in management of abiotic stresses. We work with biostimulants which can recover plant growth processes after stresses, as well as help plants to grow, for example, on the saline or flooded soils. And we also can work in some bioremediation direction, for example, on soil polluted by oil wastes or others. Besides that, I want to point your attention to this data. There is a separate presentation available on our Facebook page. Additionally, very recently, a few days ago, AgroPage published an article about overview of our database of trials, which is more than 2,000 trials. So we have very interesting and different direction analysis of how biologicals works on different crops, on different application methods, on different like functions, like comparison of nitrogen fixers to phosphorus solubilizers or to mycorrhiza, application of mycorrhiza together with inoculants and separately, and much more data. So I recommend you to look through. It's quite interesting. Coming closer to the topic, soil health. Soil health stands somewhere in the middle of our work because we try to keep soil alive, and actually our mission of BTU, new mission, is not new, but new formulated mission, is to keep the airs alive. So in soil, you know, in Ukrainian language, soil and airs is the same word. So we want to keep the soil alive and we want to keep the airs alive. So a lot of our technologies are focused on this. But soil health in definition by FAO is about the sustainability and about the like long-term productivity. So it's very important to keep the all parameters of soil stable or not degrading. So if we speak about the elements of soil quality, we can distinguish physical, chemical, and biological properties. Most of us very often speak about physical and chemical parameters as soil pH, amount of nutrients, amount of organic matter in soil, but not so often we pay attention into the biological side, like biodiversity or enzymatic activeness. But we in BTU start looking on it recent decade and longer, and I will show you a few examples of how it's look like. Besides that, there are some global kind of and general recommendations how farmers can improve carbon storage and improve their technologies to keep soil more in better conditions. So FAO in 2021 accumulated these recommendations in a few like books. And if to summarize these recommendations, we can distinguish some general recommendations like soil organic cover. This means that scientists does not recommend to keep soil empty. They recommend to use like cover crops and other techniques to not to keep it just black soil. Second thing is crop diversification. This means traditional rotation. So it's important to keep some crops like legumes which improve soil properties. Then tillage, you know, invest west part of the world. I mean, like in America, in North America, in Latin America, and also in some countries of the Europe, no-till technologies are already quite widespread. For example, in some countries of America, we can see up to like 70-80% of arable land under limited tillage. And this work quite efficiently, and this helps to preserve soil properties. Then there is a direction of nutrients management. So here it's quite complex. So there are different alternatives like using of compost and or organic fertilizers, which can return directly organic compounds into soil. Then we can have different fertilization tools like how they call it, urea inhibitors or different granular fertilizers with some solutions which improve efficiency of the fertilization. Biochar, but also FAO distinguish alive microorganisms among these instruments. So here we have huge experience and we'll show you it, but FAO also recognized biofertilizers and alive microorganisms as one of the solutions to improve soil health. Besides that, there are some techniques for soil and water conservation. This is more about the agro technologies and limited soil disturbance. It's again connecting somewhere with tillage, but also about some kind of sometimes soil needs some rest, and this can be part of the agro technology. So on this, I would like to give a word to my colleague, Yaroslava, to tell us a little bit more about natural processes in soil connected with carbon. Yaroslava, are you with us?
Yeah, hello, I'm with you. I'm happy to see you all again. And Dmitry, just a small thing. A few minutes, like 1 minute ago, I heard that the recording was stopped and that you are a host now. So who did the recording process and what is with...
You can start the presentation and I will check with our IT colleagues about the status. So you can start and I will help you with slides.
Yeah.
Changing.
Yeah, okay. Oh, I see that Roman has recently joined and I think he will fix everything. Okay, thank you. So just a few words to introduce myself. My name is Yaroslava and I am a plant physiologist at BTU. And I will tell you a little bit more how nature works in carbon farming and how we can use the microorganism to enhance this process. Next slide, please. Why microbes are so important in our life and in our soil? We are just getting more information about this, and currently scientists are pretty sure that yes, scientists claim that all the microbiomes on Earth, including microbiomes of animals, of plants, and people, human, and of the soil, they're interconnected. And the microbiome of the soil influences the microbiome of our organisms. So it is very important to have healthy microbiomes in the soil because they will make us healthier. And it is very interesting trend in science, and I think we will get some more interesting information in the near future about this. Next slide, please. So as it was said on the previous slide that microbes run this world, and it is true because microbes are the first organisms and they're the most abundant. It is stopped again. I don't know what's going on.
Don't worry. Recording is going on
Okay.
the Facebook page, so you can continue.
I will record it. Okay, great. Yeah. So microbes are the most abundant the most abundant organisms on the Earth, and we can say that all the processes connected with literally everything on the Earth, connected with living organisms, are managed by microorganisms. And on this picture, you can see that in the soil, all the processes of water storage, of organic matter formation and transformation, processes of detoxification, all processes of nutrition like nitrogen fixation, potassium and phosphorus mobilization, and degradation of residues, they're all done by microbes. And in the soil, microorganisms create a very complex ecosystem where all those species, they interact with each other. And what we know now, yes, is that the more abundant microbiome we have in the soil, the more resilience we have, and the healthier are our plants, and the more fertile are our soils. Sorry. Next slide, please. So let's dive a little bit deeper in soil organic carbon and what is going on with it in the soil. So how it works? Basically, we have a lot of CO2 in the atmosphere, and plants are the only organisms on Earth who are capable of sequestrating it from the air and fixing it in their organisms, and after that transforming into organic matter in the soil. So photosynthetic organisms are the only living objects who are able to do this. And there are two ways how organic compounds move into the soil from plants. The first is the most evident, is when plants die, their residues decay in the soil under the action of microorganisms, and in this way some simpler molecules are formed and stored in the soil. And the second mechanism is less maybe popular, I would say. It works via root system when live plants move photosynthetic compounds like sugars, amino acids, and so on, so very small compounds through root exudates into the soil. And this pathway is very, very important, because most of people think that the only way to get organic matter from plants in the soil is only after harvest, when we have dead biomass. But it's very important to keep in mind that live plants, especially with strong root system, will enrich the soil with organic compounds also. And the second part of the job is done by microorganisms in the soil. So what they do, they utilize these compounds, and they cleave them into simpler molecules of a smaller size, and they use it for their own metabolic needs. And they also produce stable organic compounds, which are very complex, like humic acids, which are very big substances. And it is the way how organic matter is stored in a stable, like in a stable form in the soil, and it is less prone to biodegradation than small compounds. And it is also important to mention that microbial community produces very high metabolic activity, and in this process they respire some CO2 back to the atmosphere, so they create a sort of loop. So they not only sequestrate organic compounds, but they also respire some CO2 in the atmosphere, where it can be used again by plants. So it's kind of loop. Next slide, please.
Yaroslava, can I ask
Yes.
you please to start demonstration, because people see only me, not you, on our translation, and I think it would be better if they see a speaker. So
why they don't see me? I don't know.
no, it's just when somebody presents the screen, then audience see only those who present. So if you have it open,
Okay.
can you please
Yes.
demonstrate?
So yes. So yes, just a moment. I think yes. Okay, so in Zoom, I should first of all make a demonstration, and after
And
that,
choose demonstration of the screen.
yes. Mm. So
Oh, it's starting. Oh,
is it full? No, it's not full screen. Yes.
yeah.
Is it full screen or not?
No, it's now we see the presentation file, but not the demonstration.
You don't see slides. My God. Okay.
Yeah,
So
no problem. We can wait this.
I'll try sharing the entire screen.
Oh, I think now it should be well.
Is it working?
Yes, we see all the screen. So sorry for interrupting you, but I believe it would be better for
Yeah.
the audience.
Is it? So now it's perfect. Yeah. Cool. Okay. Great. Yeah, and it is more convenient to me for sure. So just to summarize, so the aim of common work of plants and microbes is to create stable carbon compounds in the soil, and these stable carbon compounds are called soil organic matter, and they're very, very important for soil fertility. Everyone wants to have as much of soil organic matter in the soil as possible because it is very good in improving water storage and also nutrient uh, content in the soil. So and here are microbes. And let's move on to carbon credits and all the stuff connected with them. So how it is done in general in the world. So how to calculate carbon sequestration? First of all, it is like a consensus in the world to calculate soil organic carbon, which is stored in the form of organic matter in the soil. And we claim that the more we have soil organic carbon in the soil, the more the soil has sequestrated carbon in the past. And to calculate the compensation amount, we can just measure soil organic carbon content in the soil like every year or several times a year, and to monitor the general dynamics of this process of maybe we are increasing this content or we could be decreasing if we are applying some not regenerative but degenerative practices like deep tillage and burning the residues and so on. And companies like Agreen, there are a number of companies who provide carbon credits in the world, but here is an example of a greener company. They use to monitor carbon sequestration process. They use precision agriculture tools. The most evident are, of course, collection of soil samples using maps with GPS in order to take a sample from the same point each year, so the results would be accurate. And besides this, they're using satellite images and agro drones to monitor other practices which are used by the farmer. Why it is important? Because regenerative practices include using cover crops, incorporating plant residues, crop rotation, and of course soil tillage type. And these systems of monitoring are used to make sure that the farmer is using regenerative practices, that it is not trying to fraud the company to say like I am doing no-till and to do no-till only on the borders of the field and to do deep tillage in the middle. So to avoid this, to make everyone to be honest, such systems of monitoring are used. And currently, they claim that they compensate around 32 to 36 euros per hectare per one CO2 equivalent, which is equal to 1 ton of sequestrated CO2. And why all these credits work? What is the source of this idea? We know that CO2 is one of the main causes of global climate change. I know that maybe everyone is experiencing its consequences on their own, like this summer is it is abnormally hot, and currently, while I'm doing this presentation, it's plus 36 outside and plus 30 inside. Yes, so it is kind of hot. Yeah, and different companies and governments and organizations around the world decided to do something with that to decrease such negative consequences. And they decided to become carbon neutral. Some of them decided to become carbon neutral to 2030, which is pretty close. Others decided to do it by 2050, which is more realistic, but we will see. And their aim is to not to decrease the number of their production, but to find the way to compensate their emissions. And how they do, they find farmers who apply regenerative techniques to their soils and increase their carbon sequestration capacity. So the manufacturer creates emissions and farmers decrease them, they sequestrate them by the soil and plants. And this is, in a nutshell, how carbon credits work. On the left-hand side, you can see a very simple scheme, like we have CO2 in the air, and plants use it in the process of photosynthesis, and they move it into the soil, and they contain a stable pool of carbon in the soil, and it is very beneficial for our environment. And let's do some calculations with soil organic carbon. It will be a little bit difficult maybe, but I think I did my best to make it clear. So let's move. If we take a molecule of CO2, of this gas, it contains of two compounds, it's oxygen and carbon. And when we calculate their relative masses, we may say that a molecule of CO2 contains of 42% of carbon and the rest is oxygen. And when we analyze soil organic matter, when we analyze the amount of pure carbon in soil organic matter, because we have a plenty of other different elements in it, we may also see that it is approximately, it's 58% content of carbon in soil organic matter, and the rest 42% is for the other elements. And when we move closer to the soil, we can see that depending on the soil type, soil organic matter content in the soil will range from 1% in poor soils and to 6% in very, very rich and fertile soils. But on average, it will be like 2-3% in most European countries. And when we take a layer of soil per hectare, so imagine we have 1 hectare of the soil and we take a 30-centimeter layer and we weight it, and we will receive around 3 million kilograms per this hectare. Again, it is very approximated, it depends on the soil type. Clay soil will have a higher weight, it will be more than 4 million kilograms, but we cannot include all the types of soil possible. It will be technically very difficult, so approximately 3 million kilograms. And when we take this number 3 million, when we calculate 1% from it, it will be 30 tons. And when we take 6%, it will be 180 tons. So in this way, we can calculate soil organic matter content in arable layer of the soil. So 2 to 3% will be like 60, 90 tons of organic matter per hectare. And keeping in mind what we see on the previous slides, that 1 ton of CO2 equals to 720 kilograms of soil organic matter. And when we try to display it relatively to the total mass of topsoil, we will see that this is how 720 kilograms look like. It's very, very thin line. And what I want to say in this way is 1 ton of CO2 is 1 carbon credit, and it may sound like a lot, but when we take the whole topsoil mass, that is not that huge number. It's very, very small. And speaking about trials we have with our product, a little bit more details. It was carried out in Ukraine, and we tested different types of our destructor Ecostern, and we applied it. We see different variants here. In all of them, we applied our microbial product with nitrogen fertilizer, because we have to provide a source of nitrogen nutrition for bacteria and fungi, because they need it to produce enzymes, and enzymes are very important to cleave plant residues. So we added our microbials into the soil, and after that we measured labile carbon content in the soil. And what is labile carbon? These are molecules which are smaller than humic acids, because they are not transferred yet into a stable carbon pool, but they are still in between. So these are not simple compounds made just by digestion of microbes, but they are still not humic substances, and they have quite significant chances to move into a stable pool of carbon, which is so interesting for us. So what we can see here is that application of biologicals allows us to increase soil labile carbon content on average for 0.19%. And yes, it sounds not that much, but keeping in mind that we have 3 million kilograms of soil per hectare. With this small percent, we will have around 6 tons of organic compounds per hectare. And when we do like back calculation to how much CO2 per hectare it would yield, it you can see it on the right, it is more than 8 tons of CO2 per hectare. So it is 8 carbon equivalents per hectare, and it is pretty impressive. And some words about mechanisms how soil microbes may enhance carbon sequestration. There are 3 key mechanisms, and the first one is that microbes do the job to transform simple compounds of plant origin and microbial origin into a stable organic matter. So how it works, here we can see yellow live microbes who are actively consuming plant exudates and plant biomass. And when they die, they produce a so-called microbial necromass. And these dead microbes are afterwards absorbed on mineral particles of the soil, and they become stable. And this is the way how organic compounds are stored or fixed in the soil. So it is very important that each molecule of plant origin has to first of all be consumed by microbes, and afterwards they become stable organic compound. Without microbes, it is impossible. Second point is stable aggregates formation. It is about soil particles, because soil aggregates are key to soil structures. When soil has no aggregates, it's desert. It doesn't have structures simply. and microbial polysaccharides, microbial polymers are essential for formation of such stable aggregates. They're like small clumps in the soil, and they're very important to not only to create a structure which is very favorable for plant roots to grow through them, but also it protects organic substances from oxidation, so it creates an envelope to protect them from environmental factors. And also it prevents soil erosion processes by wind and water, so creating a well-structured soil is a job that is done by microbes, and it is very important for soil fertility also. And the third, but the last, but not the less important, is plant growth stimulation. As I previously mentioned, one way of carbon compounds from the plant to the soil is via root exudation, via root system. So when soil microbes stimulate beneficial soil microbes for sure, when they stimulate plant growth and plant root system development, in this way they stimulate organic compounds and excretion, because first of all, the bigger root system we have, the more organic compounds can be moved into the soil, and the healthier the plant is. Of course, it has higher photosynthetic capacity. And the second very interesting point is that plants and microbes, they communicate in a chemical way. So soil microbes may stimulate plants to excrete more organic compounds into the soil, because microbes need them for feeding, but at the same time they will provide some important compounds to plant, like phytohormones, other growth stimulating compounds, and also they will improve plant nutrition. And here is how it works. So we have in general a big problem with soil fertility in intensive agriculture, and we know the great problem with phosphorus fertilizer, because the bigger part of phosphorus fertilizer quickly becomes unavailable for plants because it absorbs on soil minerals, and plants cannot consume it after this. And it depends on the soil type, because in alkaline soil we will have more minerals with calcium, and in acidic soil we will have more minerals with iron and aluminum. And we come up with such situation when we have high content of phosphorus in the soil. So when we do soil analysis and compare samples from agricultural soils to natural soils like forest or grassland, we will see a very high, significantly higher content of phosphorus in agricultural soils. But the problem is that it is unavailable to plants. The part which is available for plants is very, very small, and this problem can be solved by microbes, because they are able to make undissolvable minerals available to plants, and to move them from that unavailable pool of immobilized phosphorus into forms which can be consumed by plants. And here is why it is important to maintain a healthy microbiome in the soil, because when the microbiome is disrupted by high pesticides use, by deep soil tillage, by poor crop rotation, we have a lack of microbes which are able to improve plant nutrition. And here are some mechanisms how microbes improve plant nutrition and how they perform nutrient transformation. So the main mechanism is that they produce organic acids, and they simply dissolve insoluble phosphates and other minerals, and improve nutrition of plants. Soil also contains organic compounds which contain phosphorus, for example, of plant origin, of dead residues. And microbes are also able to produce enzymes which cleave these organic molecules and also produce phosphorus for plant nutrition. There are also a groups of microbes which are able to fix molecular nitrogen. There are two groups. One of them are free-living bacteria, like Azotobacter, and the second one are symbiotic bacteria, which are able to create nodules on roots of legumes, like Rhizobium, for example. Other mechanisms include also siderophores production. Siderophores are natural chelators for trace elements like zinc and iron and copper, and they improve not only potassium and phosphorus and nitrogen nutrition, but also supply of trace elements. And mycorrhizal fungi are able to increase absorbing surface of root system and to improve water supply, which is very important in our condition of global climate change, when we have a very severe drought and other climatic problems. So in few words, to summarize, microbes do a lot of job in the soil, not only with carbon sequestration, and all these processes are interconnected. So we cannot say that there are some particular microbes that are only focused on carbon sequestration. No, all of them have a number of functions, and at the same time, while these microbes are improving carbon sequestration potential of the soil, they're also stimulating plant growth and they're improving plant nutrition. So they work in many different ways. So that's it from me for today. I think we will have Q&A session after, yes, in the end, yes.
I think, yeah, because we will see how many time we have, but still,
Yeah.
let's finish the main section. So we will ask Yaroslava to be with us after. If somebody have any questions, please note them and ask in the end. And I just want to add also an important point that we feel that carbon sequestration could be additional benefit from using of biologicals, because always we focus on yield. First of all, it's important to farmer what he get directly this season after application of biofertilizer. But this carbon story can be additional source of income for the farmer for you after use such products like Ecostern. And this could be quite sufficient. From some of the examples which Yaroslava demonstrate us, we calculate that after 3 years of using Ecostern, farmer increase organic matter in soil like up to 0.1, 0.2%, which can be equal up to like from 100 to 200 additional euros from 1 hectare of income for the farmer. So it's really an important story, and we have plenty of ongoing projects in Slovakia, for example, in Bulgaria, and in Ukraine, of course, for getting more data, getting more certified data about this potential. So keep in touch with us. We will inform about that. But now we will tell you about what we already have. So in general, we already mentioned the global challenges which we which we face with biologicals. It's carbon sequestration, it's phosphorus solubilization, nitrogen fixation, it's alternative to polymers and synthetic adjuvants, and of course abiotic stress management. So today we will speak more about Ecostern. So a few words about it. So it is a complex product based on complex composition of bacteria and fungi, which accelerate the composition of crop residues, accelerates carbon sequestration, and provides some additional benefits to the soil qualities. One of which, for example, is neutralization of phytotoxins. We have liquid and dry formulations of this product. Dry is more suitable for more arid countries. Liquid is a little bit more economic, which we use in East Europe. So about the role of each strain, more or less, again, all microorganisms are quite polyfunctional, but For example, here we can see that Panibacillus can fix nitrogen, Priesta can improve solubilization of phosphorus, Agrobacterium can do nitrogen fixation, and Trichoderma produce a lot of enzymes which accelerate again the composition of plant residue. So again, it's not a messy explanation of all these strains, but some of the what they do. So when farmers use EcoStern, we give them some kind of general recommendations how they can see that product work. So first of all, they can check the composition of plant residues after a few months after application. Dmitry will tell about this a little bit later. Secondly, we can monitor some physical and chemical biological soil indicators, and we of course can monitor the development of next plant on the field. Besides that, there are some laboratory methods. Some of the examples of such tests I will show you. So I believe this slide a lot of you already have seen a few times, but still we want to again pay attention to this method, Biotrax. Biotrax is a Japanese technology of estimation of soil enzymatic activeness. They use this kind of plates and gives a kind of integrated assessment of soil quality and soil activeness. Besides that, they evaluate functional biodiversity of soil. So we first time use this method with them to test how EcoStern can return microorganisms activeness to the dead soil. It's a kind of sterilized soil. This soil was treated with EcoStern in the industrial dosage, and we return we return soil functionality almost to normal level. Why it is important? Because, for example, more and more we meet farmers who practice some of methods to sterilize soil. For example, in Germany we visited quite a big farmer who used kind of steam sterilization of soil. In Turkey, we visited greenhouses who use solarization of soil. In Greece and in some other countries, we meet some farmers who use some kind of copper or other chemicals also to sterilize soil. They use it with the idea to suppress pathogens, but in fact they kill all alive what is in soil. Also in Ukraine, some of the farmers, for example, use sorry if I make mistake in definition, but dehydratized nitrogen, some strong nitrogen fertilizers which also kill everything in soil. So all of this is not beneficial to the biodiversity, and what we recommend is, even though farmer use such kind of practice, to return functional microorganisms, PGPR, fungi, into soil, so that all those processes which Yaroslava explained us for nutrition solubilization and carbon sequestration and all other important things continue happen in soil, because otherwise it's dead. So some other examples of Biotrax use as instrument to evaluate EcoStern effect on soil. So this trial was done in Germany. There is organization CO2 Land. We start some project with EcoStern with them last year, and we monitor this project during last year. So besides visual check, we also did Biotrax to evaluate this enzymatic activeness in soil. So what we find out that in both fields, both in liquid and dry form of EcoStern, we reach improvement of soil activeness from 10 to 30%. And also in both cases, we improve soil ecophysiological biodiversity. So we believe that there is place of EcoStern in regenerative farmers' practices, and we get more and more data which proves this idea. This table is quite complex, but I want to explain here importance of correct trials setup in use such methods as Biotrax, but not only, also in using any idea of checking influence of biologicals on soil properties. Even you do agrochemical analysis or others. Very important is to do estimation before application of any products on all plots. What we see here. Why it is important? Because, for example, if we take this field with strip till, we can see that on control plot, activeness of the soil was very high. In the same time, activeness of the soil on the plot with very later apply Ecostern was, I don't know, 30–40% lower. That means we have different starting points. But then we do the second estimation, like after application of the product, more or less in 1 month. What we see on the control, there is a negative dynamic of soil activeness, minus 100,000. At the same time, on variant where was Ecostern, we see improvement of activeness of soil. So if we take only one analysis, like here, after 1 month after application, we could make idea that Ecostern did not improve soil activeness. But in fact, while on the control it was declined, on the variant with Ecostern it was improved. And the same story we can say about biodiversity. So very important is to do a correct setup of the trial, and in this way we can make a more correct conclusions. And another not summary but conclusion from this trial is that in Ecostern improved soil activeness in both traditional tilling technologies and limited tillage technologies. Besides that, in our practice, we do some more simple, some were simple, some were no, but another tests. We do traditional agrochemical analysis, we do some mycological analysis and microbiological, like bacterial analysis. So in this case, there was a trial where we used Ecostern together with our phosphorus solubilizer ground fix. So what we reached to find out that these biologicals improve amount of available phosphorus and kalium in soil. These products combination improve increase amount of fungi in soil, and these products also increase the amount of bacteria in soil. So more or less the targets of application of these products were reached. Then a few words about the carbon sequestration itself. We had some trials. Actually, some of them are almost 10 years old. So we really study this topic for a long time. So one thing we find out that Ecostern does not increase significantly evaporation of CO2 from soil. Second thing, we find out that Ecostern really improves accumulation of labile organic compounds in soil, even after like 30 days tests. Again, we have seen another tests with kernel in field after 3 years of application, which also confirms this idea. Third thing, we check activeness of Ecostern on different soil types. We see that, yes, in different soil types, the composition goes in different speed, but in each case, Ecostern increase this process. In this RIGHT project, again, it was more than 10 years ago, we studied and confirmed that Ecostern accelerate accumulation of organic matter in comparison to normal technology. And we also find out that systematic use of Ecostern also improves physical property like soil density of the soil. This test was already shown by Yaroslava, but again, I just want to point that in comparison to control, different formulations of Ecostern increased amount of labile carbon compounds in soil after 3 years project. In the same project, we estimate amount of micromycetes in soil, especially trichoderma, and we also can find out that there is a positive dynamics to increase amount of such important saprophyte as trichoderma in soil after use of Ecostern. Then this is a new test which we done recently. In this test, we estimate kind of activeness of photosynthesis in the leaves of potatoes on the plots where Ecostern was applied in comparison to the control. So you can see that what is interesting, because Ecostern is applied in soil, even though it still improves activeness of photosynthesis in plants. So on this, I would like to give a word to my colleague, Dmitry, to share some practical experience of Ecostern application. While Dima is connecting, I'm a little bit excused for a little delay of finishing the presentations. Probably we would need another 20 minutes for you.
Okay, thank you. Hello, everyone. I'm very happy to see you again and again. And I would like to share your information with what questions we met, and also I think you have the same questions to us about this product. I have one question to you only. Do you hear me well? Okay,
Yes, we hear
thank
you well. Good
Yes,
question.
perfect. And Diedrich is joining now.
Thank you. Hello, Mr. Diderik. Yeah, as you can see on this slide, we have a lot of different questions from year to year, and I will try to draw your attention on our answer from practical side. As you can see, we have a lot of questions how to check the destructors work, like Dmitry already said. For what types of soil we can use Ecostern? Does dry formulation of Ecostern work same as liquid? And what our recommendation is the best? It depends on what situation you have. Compatibility with fertilizers, it is very often questioned to us. How to increase the efficiency of the destructor? I think I would share your information. And we will start from our first question. It is Ecostern effective in arid regions? As you can see, we used Ecostern in 2019 before plowing for system deep non-moldboard cultivation, and also shallow non-moldboard cultivation. As you can see, this from this side it is control. From yellow color, orange color, it is Ecostern. As you can see, in for different type till of soil, we have better result for decomposition of plants residues is better. As you can see on control was 27% decomposition level of decomposition of plant residues. With Ecostern it was 66. And also I would like to pay your attention in different types still of soil, we have better result for the composition of plant residues with Ecostern, where we used Ecostern. And also in this table, we are sharing information about efficiency of Ecostern in no-till technology. And also, as you can see, we had winter wheat, sorghum, and spring barley in different years, different seasons. As you can see, process of work of Ecostern provide us not only better structure of soil, also Ecostern has influence on better feeding it means that feeding of plants. It means that Ecostern also can provide us more available form of micro and macro elements in the soil. As you can see, application of Ecostern provide us increasing the yield on this type of crops from 150 up to 850 or 140 up to 850 kilos per hectare. Also, as you already know, I hope you know that we have a few types of Ecostern. It is like liquid formulation form and dry form of Ecostern. And also we have a few different contain of Ecostern. It is like bacterial, which based it on only on bacteria. Ecostern Classic, you know this product may be the best from all of these types of Ecostern. Also, we have Trichoderma, contain of this type of Ecostern, based on few species of Trichoderma, and also Ecostern Light. We used these products. Which type of products we used? It depends on what conditions we have, soil conditions, climate conditions. But I would like to draw your attention on Ecostern Classic because you know this product, and also this product content of this product is like more universal for all different types of soil. And a little later I will show you information like how this product works in different types of climate and soil conditions. As you see, we used the classic formulation of Ecostern liquid form, 1.5 liter per hectare, and it is provide us increasing the yield 160 kilos per hectare. And also I would like to draw your attention that it was crop sunflower. And also Ecostern Classic dry form, we used only half a kilo per hectare. And I think from all of my colleague partners, Mr. Stefano from Italy has very big practice with dry formulation of Ecostern in Italy. And also, as you see, we have increasing the yield 200 kilos per hectare. And as you know, sunflower is a crop which have very good profit for producers. One more our trial from Germany, who took part in our international meeting previous year, last year. This our partner see result during vegetation period on the field. As you see, we used different amount of mineral fertilizer. As you see, we used 100% of mineral fertilizer, and also we reduced amount of mineral fertilizer with our products. As you see, on control place plot was only 75% of mineral fertilizer. Also, we had a ground fix 3 liter per hectare plus 100% of mineral fertilizer, and also, as you see, we used such a complex of products with 75% of mineral fertilizers. As you see, some our complex method of application of our products like EcoStern Ground Fix and AzotoHelp EcoStern Ground Fix provided us the best result on a corn. Sorry. And also a little more statistic from our trials during a lot of years. As you see, we used EcoStern after previous crops before sowing of cereals, corn, sunflower, soybean, rapeseed. As you see, we have very high successful result after application of EcoStern. As you see on cereals, average increase in the yield was around 300 kilos per hectare. On corn, this quantity was around half a ton in average. For sunflower, it was around 200 kilos per hectare, increase in the yield. On soybean, it was around quarter ton, and for rapeseed, it was around 150 kilos per hectare, increase in the yield. A little more visible effect after application of EcoStern from Germany. As you see, we used EcoStern in autumn in 2019, and you can see on this photo result after application, which we fixed spring 2020. From this side, it is trial. As you see, a better root system and better development of green mass in comparison with control. As you see, more light color from this
Bottom.
level of plant, and also worse development of root system. Also, as you see from this photo, where we used 2 liters per hectare of EcoStern, plant residues is not strong. And when we have such result, it means that we sometimes when we didn't use EcoStern, we have problem with sowing process, because these plant residues which still strong, it creates us some problem with sowing when we blocked sorry, maybe it is not correct, nozzles for seeds. Also from this trial, as you see, from control place, we have big and strong plant residues. From trial place, we have dark and miyaki. Soft plant residues. And also very important for us that EcoStern, it is like a complex contain which provide us few effects. As you see, root system after application, also it was organic corn. I would pay your attention on root system. As you see from trial place, root system is better than from control. And also, as you see, we have more kernels from trial place, from 3 plants, than from control place. And also, I think you already see, and you already saw this photo, but it is very, very good visible effect after application of EcoStern. As you see, from this place, we have yellow leaves from this level of plant in comparison with these plants from trial place. We have more greener. It means that vegetation period of plant plants still continue, and these plants provide us more yield and better quality of yield. Also, our partner from Slovakia, I think, already has very big experience with this product, like with liquid formulation of EcoStern. And also, I would like to draw your attention on this picture. It is after application of EcoStern. It is control place. It is trial place. As you see, we have very nice visual effect. And also, I know that you have a lot of customers, a lot of clients who has horticultures, and also we have practice from when we work with EcoStern in gardens. As you see, we used a few field complex for application of EcoStern, like EcoStern without nitrogen and EcoStern with nitrogen fertilizer. As you see from this side, it was before application. This combination of products, and after application. As you see, I would like to draw your attention that effectiveness of EcoStern in comparison with control, where we didn't use some biodecomposers. When we used EcoStern with urea, the composition of leaves was better on 37%, where we used only EcoStern. It will be better for organic farms, for example. The composition of leaves was better a little more than 11%. Also, I have our company have questions from Italy, from Spain, from Greece, from other countries about rice stubble. And also we already have few trials on fields, and also we are finishing lab trials, which we make during 3 months. We will share to use this information a little later, but I would like to draw your attention on what trial we already have. As you see, we used EcoStern, experiment number 2. We used EcoStern 3 liter per ton of stubble, rice stubble, and plus 40 kilograms of urea. As you see, it is provide us better result for the composition and for better feeding of crops. And also, I would like to draw your attention on this result, where we used EcoStern. Application of EcoStern provide us better yield, bigger yield. It was around plus 600 kilos per hectare. And also, how we can strengthen the effectiveness of EcoStern, or also it is I would like to draw your attention that all previous slides I showed you when showed the information when we used EcoStern plus some nitrogen fertilizers. It is more for traditional method of growing our crops, but also we can recommend to use EcoStern together with other our products for better, for example, better, faster and faster effects. And also, as you see, we can combine EcoStern plus LipoSum. Our recommendation to use such combination for extreme conditions like droughts and extensive soil moisture. And also, this combination show very nice result for no-till technology. Also, we recommend to use EcoStern plus AzotoHelp for additional nitrogen nutrition when we have poor soils. And also, we recommend to use EcoStern plus Humifren for faster activation of microbes. In case of late application, when when you have problem with some not good conditions for applications, or your clients have problem with have some technical questions which don't provide us to do our sewing in time. And also, all these products, a rate for all these products for all ways is half a liter until 1 liter per hectare. And also, I would like to remind you that we already have a database with all our webinars and information from previous year. As you see, we have like a library with previous our webinars. Please, you can find all these webinars and also you can remind you for yourself information what we can recommend and what practice we already have. Yes, it is all information which I wanted to share you. And also you have all my contacts. I will happy to help you with all your questions. Thank you.
Super. Thank you for the presentation. Now is a moment for the questions, if any, or for the comments, if any. So I'm very happy again that a lot of our partners systematically join us on these sessions. Yeah, so I would like actually to ask you to open cameras so that we make see you. Normally, after these sessions offline, we can do a kind of collective photo. Online, it's not so touchy or friendly, but still, we are very happy to see the faces.
Dima, only one thing. Can you please provide the latest slide of Chernenko's, because it was the QR code for downloading all the seminars. I got it from Germany, but just to be sure that they got it. No, not the last one, but the previous one.
Is QR
Ah,
code.
that one.
QR code.
That one with the QR code. Thank you.
Super. Besides that, I want to comment that today with us were nearly 30 people in Zoom from 17 countries, from Europe and Africa, Germany, Ukraine, Poland, Italy, France, Bulgaria, Macedonia, Romania, Slovakia, Cyprus, Spain, Croatia, Lithuania, Belgium, Moldova, but also Zambia and Tanzania. So we are very happy and thankful for those who join us. So, any other comments or questions? So I will give you another minute to decide about the question. So again, thanks everybody for joining. I believe that the topic is will
Dima,
keep
Dima.
its yes.
Sorry, I think we have one question from Oksana Balanda.
Oh.
Dostaniemy materiały na maila później po skończeniu webinara. Materials.
Yes, we will
Presentation,
send you.
Yes.
tak?
We will
Dzięki.
change, yes. So what I wanted to say is that the topic is trending, and we believe it will only become more important because climate continue to change. It's very extreme conditions now in Europe, especially, and soils. There are reports like soils in Europe are quite degraded already. So we will keep caring of it, and but the longer we go in traditional practices, the more difficult situation becomes. So we will continue our research and practice to provide farmers with solutions to improve their agrotechnologies, to improve their soils, to keep the earth alive, and to keep the soils alive. So if we don't have any further comments, thank you all for visiting us. Look forward for further communication, and have a nice end of the week.
Thank you.